Okay, in lesson 1, we talked about what exponents were and what that means, what each part of it means. Today, we're going to make sense of the first law of exponents. The first law of exponents deals with multiplying and dividing bases with exponents. Okay, so if you had 3 to the 5th power times 3 to the 7th power, we learned in the last lesson that that 5 means we multiply this 3 5 times. And all of that is being multiplied by 3 to the 7th. The 7 means we multiply this 3 7 times. So if you were to work all of this out and count your 3's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This would give you a result of 3 to the 12th power. But what if you had exponents in the hundreds or thousands? You wouldn't want to write all those numbers out. So there is a rule that when you multiply exponents with the same base, now they both have to be the same. If one of these was 3 and one was 4, it wouldn't work. But since they're both 3, then you can add your exponents. 3 to the 5 plus 7 equals 3 to the 12th power. So example 1, both of my bases are 5. I want to transfer my base of 5. My exponents are 2 and 4. Since I am multiplying, then I add those 2 exponents, 2 plus 4. And my result is 5 to the 6th power. Example 2, our bases are both negative 2/3. So I will transfer my negative 2/3 over. Remember that it's a negative number and a fraction, so we need this in parentheses. My exponents are 4 and 5. I'm multiplying. So my final answer is 2/3 to the 9th power. You can pause here and work out exercises 1 through 8, and I will give you the answers when you finish. Exercise 1, your base is 14. Add 23 plus 8. You get 14 to the 31st power. Exercise 2. Negative 72 to the 23rd power. Exercise 3, both of my bases are 5. 5 to the 94th plus 78 gives me 5 to the 172nd power. Exercise 4 is negative 3 to the 14th. Now when we get to exercise 5, it doesn't matter that the base is the letter A. It's still the same base. So we just transfer our letter over and add our exponents. And we get A to the 31st power. Exercise 6, both of my bases are F. So F, add your exponents. Your answer is F to the 23rd power. Exercise 7. Both of your bases are B. You'll add 94 plus 78 and get a final result of B to the 172nd power. Now look at number 8. Instead of us adding our exponents, we know that 9 plus something has given us 13. I need to figure out what that something is. 14, sorry. You could do that by subtracting 14 minus 9 to get 5. So your x should be 5. It doesn't matter how many times you multiply exponents with the same base. Earlier we were just having to add 2 exponents. Now all my bases are still the same, so I would transfer my 9, that's my base, and I add my exponents, all of them, which would give me a result of 9 to the 23rd power. You can try exercise 10 and pause here. Exercise 10, my bases are all 2. I'm multiplying all of them, so I'm going to add my exponents. 3 plus 5 plus 7 plus 9 would give me 2 to the 24th power. When you get to exercise 11, I told you earlier that you can only put together exponents if they have the same base. 6 and 4 don't have the same base. But I do have 6 to the 5th and 6 to the 14th that I'm multiplying together. So I can add the exponents of those numbers by the exponents of the other numbers. As long as you don't put them together. So your answer would be 6 to the 19th times 4 to the 12th. And that's as far as you can simplify that. You cannot put the 4 and the 6 together. You can try exercises 12 and 13 on your own. Pause here and I will give you the answers when you get back. Exercise 12. My common bases are -4 and 17. I can only put together the -4s. 2 plus 3. And the 17s. 5 plus 7. So your final answer, as simplified as you can get this, is -4 to the 5th power times 17 to the 12th. Exercise 13, my bases that are the same are the 15s. This 15 does not have an exponent. If there is no exponent and there's only one 15, then you know that your exponent is 1. So when I add my exponents for 15, I add 2 plus 1. For my base of 7, I add 2 plus 4. And my final result is 15 to the 3rd times 7 to the 6th. Exercise 14. I cannot add the exponents if the bases are not the same, but sometimes you can find an equivalent base and exponent that would have the same base as your other number. So 8 squared is 8 times 8, which is 64. If I could find a base of 2, if I could find out how many times I could multiply 2 to get 64, I could have the same base. So I want to get rid of my 8, and actually if you multiply 2 6 times, you also get 64. So what we have done here is replace our 8 squared, our 8 to the 2nd, with 2 to the 6th. Now I have the same base. Transfer my base. Add my exponents. I get 2 to the 10th power. You can pause here and complete 15 and 16, and I'll give you the answers when you come back on. All right, 3 and 9 are not the same base. But like earlier, if I have 9 to the first, that's 9. I need something with a base of 3. If you multiply 3 times 3, you get 9. So I'm going to replace my 9 with 3 to the second, 3 squared. Now I have the same bases. My base is 3. My exponents are 7 plus 2. I get 3 to the 9th power. Now exercise 16. There is no way that you can turn 5 into a number with 2 as a base. There's no way that this will work. So actually the way it is written is as simplified as it's going to get. Your answer would still be 5 to the 4th power times 2 to the 11th. All right, exercise 17. We are going to learn that regular old numbers in front of our x's, that's like having the same base. Regular old numbers can be multiplied. So I'm going to multiply 2 times 17 times x to the 3rd times x to the 7th. Just so I make sure I have everything up there. 2 times 17 is 34. Those have the same base. So I'm going to add my exponents. And I would end up with a final result of 34x to the 10th power. Exercise 18. Remember from last year, using the distributive property. That means everyone gets something. Everything inside the parentheses gets one of what's on the outside. So I'm going to distribute my A's to the A and the B. So I end up with A times A plus A times B. Earlier, I told you that if there's no exponent, it's understood that that's a 1. So if I'm multiplying A to the first times A to the first, that's A to the 1 plus 1, which gives me A squared, or A to the second. I cannot add exponents of A and B, but I can multiply those together to get AB. So your final answer would be A squared plus AB. 19 is the same concept, except this time you're distributing the B. So this time you are multiplying A times B plus B times B. A times B, you cannot add those exponents together. So you still just have one A and B multiplied together. However, my B's have the same base, so I can add that one exponent of each. My final answer would be AB plus B to the second. Down at the bottom, I have to multiply everything here by everything here. So I'm multiplying A times A times B Now I have to multiply this B times this A. So plus A plus B. This B times this B. So plus B times B. Now you just put everything together. A times A, we've already learned, is A squared. Plus AB plus AB. Those B's have an exponent of 1, so that's B squared. The only thing left to do is combine like terms. And you learned this concept last year too. Since I have two AB's, then my final result is A squared plus 2AB plus B squared. That one was really hard, so if you didn't get that one, it's okay. We will visit that again later, okay? All right, now we're going to do the opposite. Earlier I told you when you multiply exponents with the same base, you add those exponents. Now we're dividing. So in my numerator, I have 3 to the 7th. That's multiplying 3 7 times. In my denominator, I'm multiplying 3 5 times. You learned, I can't even remember what grade, but that a number divided by a number makes 1. So 3 divided by 3 makes 1. Or you've learned that they cancel each other out. So I can cancel out those 3's, those. I only put 6, I got a 7. What I'm left with are 2 3's. So the answer to what is 3 to the 7th divided by 3 to the 5th is 3 to the 2nd. But just like earlier, I taught you that there was a rule. So if as long as you have the same base, you'll transfer your base. And this time, since dividing is the opposite of multiplying, then we'll do the opposite with the exponents. Earlier we added when you were multiplying. Now we will subtract. So 7 minus 2, 5, sorry, giving you a result of 3 to the 2nd power. So example 3, we're dividing 3/5 to the 8th by 3/5 to the 6th. I keep my base of 3/5. And since I am dividing, the line means divide, I subtract 8 minus 6. I would get a final result of 3/5 to the 2nd power. Don't forget your parentheses. Example 4. 4 to the 5th divided by 4 to the 2nd. I have a common base of 4. I subtract my exponent since I'm dividing, and I get a final result of 4 to the 3rd power. I will pause here so that you can complete exercises 21 through 26. Exercise 21, I have a common base of 7. Subtract 9 minus 6. I end up with a final result of 7 to the 3rd power. My common base in 22 is -5. Subtract 16 minus 7. I end up with -5 to the 9th power. Exercise 23. I have a common base of 8/5. I subtract 9 minus 2. End up with 8/5 to the 7th power. Exercise 24. is 13 to the 5 minus 4, or 13 to the first. You do not technically have to write 13 to the first. The first tells us there's one 13. So all you have to do is write 13. If you want to write 13 to the first, that's completely up to you. 25. Just because there's a fraction in both the numerator and the denominator does not mean that anything is different. It's still the same thing. It's still the same base. So A over B, subtract 9 minus 2, and you would end up with A over B to the 7th power. Exercise 26. I have a common base of x, 5 minus 4. So I have x to the first, and again, you don't have to write the 1 unless you want to. You could write it just as x. All right, the next ones, can they be written in simpler forms? Let's look at these. We're starting to see expressions that do not have the same base. But like earlier, 4 squared is 4 times 4, which is 16. 2 to the 4th is the same thing as 4 to the 2nd. 2 times 2 times 2 times 2. That's 4. 4. 4 times 4 is 16. So we replace the 4 squared with 2 to the 4th. Now we have a common base. My common base is 2. 7 minus 4. I get 2 to the 3rd power. You try 28. 28, I have 27. 27 and 3 are not common bases. However, 27 is actually 3 times 3 times 3. So 3 to the 3rd power is the same as 27. I want to replace my 27 with 3 to the 3rd. Now I have a common base. I can subtract my exponents and get 3 to the 20th power. Just like when we multiplied earlier with exponents, you can only put together the bases that are the same. So I can simplify 3 to the 5th divided by 3 squared, or 3 to the 2nd, and also 2 to the 8th divided by 2 to the 3rd. I just can't simplify the 3's with the 2's. So I've got 3 to the 5 minus 2 times 2 to the 8 minus 3, which will give me a final result of 3 to the 3rd times 2 to the 5th. There's no further that you can simplify that, so you have to leave that as your answer. All right, you try 30. I'll give you the answer when you get finished. All right, those are my common bases. So I can have negative 2 to the 7 minus 5 times 95 to the 5 minus 4. I would end up with a final result of negative 2 to the 2nd, or squared, times 95 to the 1st. If you just put 95 there, that's fine. All right, last exercise. Since we are multiplying a fraction by a whole number, we can make this easier on ourselves and turn our whole number into a fraction by sticking a 1 underneath it in the denominator. Now I have 5 over x to the 3rd times 3x to the 8th over 1. Now you can multiply straight across. 5 times 3x to the 8th. You are only multiplying the 5 and the 3. You get 15x to the 8th. Because we can't forget about our x to the 8th. It doesn't go away. x to the third times 1 would be x to the third. Now I need to simplify my things with common bases, which are my x's. So I've still got my 15. Don't forget about your 15. And I subtract my exponents, giving me a final result of 15x to the 5th power. All right, part B. I've got my first fraction, 5 over x to the third. And like earlier, first step is to stick a 1 underneath the whole number so that we can multiply straight across. Five times negative 4x to the 6th. I'm just multiplying my 5 and my negative 4, my whole numbers, my regular numbers. Negative 20x to the 6th over x to the third times 1 is still x to the third. I can simplify my common basis, giving me negative 20x. Subtract those exponents, and my final answer is negative 20x to the third. Don't forget your parentheses because that's a negative number. Actually, no, back up. It's not on the outside because the 3 only applies to the x. So this is a good point for me to bring up, okay? You would only put the parentheses around that negative if the 3, the exponent of 3, also applied to the negative 20, meaning you're multiplying negative 20 3 times. We are not. So we don't need the parentheses for that. The last one, stick a 1 under it so we can turn that into a fraction. I've got 5 over x to the third times 11x to the 4th over 1. You finish that one, and then I will go over it when you come back. Okay, I'm only multiplying 5 times 11, giving me a result of 55x to the 4th over x to the third. Again, I simplify my common bases, not forgetting my 55. Subtract 4 minus 3, and I get 55x to the first. You don't have to put the 1. You could leave it as 55x. And that is multiplying and dividing exponents with the same base. As long as they have the same base. When you're multiplying, add your exponents. When you are dividing, subtract those exponents. And that's it.